Welcome back. We are on week 4 of the NPTEL course on engineering graphics and design. In the previous week, we looked into the basics of orthographic projections by looking at what a drawing sheet is, the scales and the sizes used. We also looked into the various lines used and the dimensioning. And towards the end of last week, we also looked into how to project simple things like a point, line, plane and simple objects. In this week, what we will be looking at is we will extend those projections to regular solids. So, in a while, especially in this lecture, we will show why we are interested in solids and how this is relevant to the regular products as well as objects we have in daily lives. Okay. So, here we start by saying that objects can be formed from primitive solids. For example, in this slide you can see a bolt. What you see at the bottom is a hexagonal prism, because the cross section is a hexagon, and prism because the cross section is uniform. On top of it you can say that there is a cylinder lying on it. So, if you look at these two separately, these are basic primitive solids. Primitive solids are something we call it as simple as cuboid, sphere, cylinder, hexagons and other polygons and solids, which we will discuss more in today's lecture. But the point to be made is, by either doing Boolean operations such as like union, intersection or subtraction, we can form more complex objects just by starting by these simple objects. So, for example, in the second figure what we see is the hole what is there in the object can be created with a cylinder. So, if you have a cylinder and subtract it from a bigger object, we create a hole. And similarly, in the third figure, which appears to be more complex, but again this can be built by starting with a cuboid for example, and then dealing with cylinders by using operations like union, subtraction and intersections. And as an example, here I have this, we can call it usually a square prism, and here what I have is a triangular prism. So, if I add both of them together, it gives an appearance of a object which is not as simple as the one which we started with. For example, this can be used as to depict a house. The point being, any complex or most complex objects can be represented by a combination of these simple solids. Therefore, if we are able to know the projection of these solids, then we can extend that knowledge to go and create projections of more complex objects. So, let us look at what are the different kinds of solids. There are many ways to classify, but we are looking at one specific way of classifying, where we say solids can be classified as polyhedrons, prisms, pyramids and solids of revolution. The reason why we are looking at it is to introduce new terminologies. Probably you might have already heard about it, but the reason is to get uniformity with everyone. So, we are introducing these terminologies such that we will be using these in the next few lectures, where we will actually look into projection of these solids. In this lecture, we are only introducing these solids and this terminology. So, let us start with polyhedrons. So, here what we see is the tetrahedron, which means it has 4 faces which are all equal. The next one is the hexahedron, which means it has 6 faces where all faces are equal sized and shaped. This you can also call it as a cube, as we all know. And lastly, the octahedron, where it has 8 faces all being the same. So, in addition to these, we also have the prisms and pyramids. So, these are typical prisms. Depending on the base, we name them as triangular, square, pentagonal and hexagonal prisms. But let us look at the terminology. So, what we see at the top and the bottom, both are called the base, and next is the axis. So, this is the axis running along the length of the prism. So, it passes through the center of the base on either sides of the prism, and once you connect it, you have this imaginary line called the axis. Next is the face. So, for example, a triangular prism will have 3 faces. So, in the standing position of this prism, we have 3 vertical faces. So, these edges which connect the points on the base, the corresponding points on the base are called the edges, or more specifically the vertical edges. Of course, vertical only is applicable when it is standing, and if it is inclined, you may have call it the inclined edge. So, similarly, the same things, the same terminology goes with the rest of the prisms. So, for example, here what I have in my hand is a pentagonal prism. So, if you look in this direction, you see it has 5 sides, and in this direction you see that this cross section of a pentagon is uniform along the length of the prism. So, the imaginary line passing through the center is what we are terming it as the axis of this prism. Okay. So, now let us look at the other category, which are pyramids. Again, they are defined by the base as in prisms. So, if the base is triangular, you call it as a triangular pyramid, square pyramid, pentagonal pyramid, and a hexagonal pyramid. So, the difference between a prism and pyramid is, in the pyramid you start with the base, which is at the bottom, and then gradually the cross section decreases, but the shape remains the same, which is the pentagon in this example, and it ends with a sharp point, which we call it as the apex. So, we start with the base and then end with the apex, and here too we have this imaginary line joining the apex to the center of the base. We call that as the axis, and of course, it has faces. So, for example, a pentagonal pyramid will have 5 faces, and now you can see these faces are all inclined, and these edges, which are the intersection of 2 faces, are these slant edges. Okay. So, to contrast, in my right hand I have a pentagonal prism, and to the left hand I have a pentagonal pyramid. The only difference is here the cross section remains constant, but in the pyramid the cross section decreases to a sharp point, which we call as the apex. Okay. And the last category we have is the solids of revolution, because there are some solids, if you take an axis and rotate them, we get a solid. For example, let us start with to get a cylinder, I can take a rectangle like this, and maybe by this from this edge I can rotate. So, let us see, if I rotate about this edge by full 360 degrees, what I get is a solid, which we call it as the cylinder. Similarly, for the cone, we can start with a right angle triangle, and let us say this vertical edge is the axis, and if we rotate about this axis by 360 degree or one complete revolution, we get a cone. Similarly, for sphere, I can start with a full circle and then make half a revolution to get a sphere, or the other way is I can start maybe with a half circle and then make a complete revolution to get a sphere. So, these are the basic solids of revolution. Of course, there are much more complex solids of revolution one can obtain by using the same principle. So, here what we need is this axis by which we rotate. So, this we call it as the axis of rotation. Okay. So, finally, when we are talking about solids, we need to specify 2 things for us to accurately describe the solid. To say that where is this located, which we call it as the position, and how is it oriented. So, how do we specify, especially in these engineering drawings? So, for that what we use is this horizontal and vertical planes, which we already discussed in previous lectures. So, let us say this is the horizontal plane and the other one is the vertical plane. So, let us say we are working in the first angle projection, which means we place the object in the first quadrant. So, this what you see is a hexagon which is placed in a very simple orientation. I call it simple because if you notice the axis of this hexagon, it is perpendicular to the horizontal plane and parallel to the vertical plane. But the object need not be always perfectly oriented. Sometimes it might be in an inclined orientation. So, like this. So, here you can see if you focus on the axis of the hexagon in the second figure, that axis is inclined both with the horizontal plane as well as the vertical plane. And let us say now we are asked to draw the front view and the top view, it is not a very straightforward job. But if the hexagon is neatly oriented as in the first figure, then drawing the top view and the front view are more easy. So, now what we will do in the next few lectures is we will first study about how to draw polygons, because let us say to draw a hexagonal prism like this, you first need to know how to draw a polygon, which here is a hexagon, and later we will see how to deal with solids and take the projections not just when they are in a simple orientation, but even in complicated orientations. Okay. So, the one point I forgot to mention is, for example, to specify the position and orientation of this solid, I was using the example of axis, saying that the axis is either parallel, perpendicular or inclined to the projection planes. But you can use any other features, like for example, I can say talk about the base. In the first figure we have the base parallel to the horizontal plane, but whereas in the second figure we have it inclined. And similarly, I can use the side of a hexagon, saying that for example, let us see this side for example is parallel to the horizontal plane as well as the vertical plane. So, maybe I can prefer to use that to specify the position and orientation of this solid, saying that this particular side is at a distance of 10 units or 20 units from the horizontal plane and it is parallel to the horizontal plane. Similarly, I can say the same side is at a distance of 50 units from the vertical plane and is parallel. And similarly, you can use the other features like the edge and face to specify the position and orientation of the solid. Okay. So, in summary, what we have discussed in this lecture is to say that most of the commonly used objects can be composed of very simple solids, and these solids are classified in polyhedrons, prisms, pyramids and surface of revolutions. And we have also introduced various terminology related to this, like the base, face, edges, sides, axis, apex and axis of revolution. So, finally, we said we can use all this information to specify the position and orientation of a solid in space by using the horizontal and vertical planes, as well as using the features of the solid like the base, face, axis, edge or side. So, in the next lectures we will be first looking at how to project polygons, and then gradually we will go into the final step of projection of these solids. Thank you for your attention.